Hello, we're looking at Unit 4, Lesson 3 today. I believe it's on page 9 of your packet. Today we're going to be able to determine the effects of transforming the linear parent function and identifying key features of linear functions. Okay, so here's your warm-up. Jessica has $24 and plans to spend it all at the grocery store. She wants to purchase bags of carrots and bagels. Bags of carrots cost $2 each and bagels cost $3 per bag. Let X represent the number of carrots, bags of carrots, and Y represents the number of bags of bagels. So X is number of bags of carrots, Y is the number of bags of bagels. Complete the equation in standard form that models the scenario. So this is pretty easy. Take a minute to think about it. You can pause the video. So carrots cost $2 each, and bagels cost $3 per bag. And we know that she has $24 and plans to spend it all at the grocery store. So there's the equation. The equation above can be changed to slope-intercept form and look like this. Y equals negative 2/3 x plus 8. Graph this equation with the appropriate labels. Okay, so we know that this is the equation. And that matches my slope-intercept form. This tells me that my slope has to be negative 2/3 and my intercept has to be 0, 8. Okay, so you can set up your little chart. This is how you're going to move. We're going to go down to right 3, and we're going to be beginning at the point 0, 8. So I'm going to go to 0, 8. And that will always be on your y-axis. And we will go down to right 3. And we'll keep doing that until you get a couple points. Okay, and you should get a nice straight line off of that. All right, looking at example number 1. Observe these linear functions on the same coordinate plane. We have f of x equals x, g of x equals x plus 5, and then h of x equals x minus 3. Notice how they're labeled by different function value letters, their function names. So we have f of x, g of x, and h of x. How do these functions relate to each other? Can you describe how to get from one function to the other? All right, take a minute to fill that in the best that you can. Look for how they're related. All right, so it looks like to me that all lines have the same slope but have different intercepts. You could also say that they're parallel. So if you took geometry last year, we talked about parallel. So the way you move to get from one function to the other is by just shifting or translating the points down however many spaces you need to get to the other equation. So for example, if I wanted to move g of x to match up with f of x, I would shift down 1, 2, 3, 4, 5 spaces. All right, so go from g of x to f of x, we'd have to shift g of x down 5 spaces. Okay, if I wanted to go from h of x up to g of x, I would start here. I would go up 1, 2, 3, 4, 5, 6, 7, 8 spaces. So I have to go, starting at h of x, I have to go up to 8 spaces to get to g of x. So that's how you can write that down. Okay, so we have our types of function transformations. We have translations and we have dilations. Okay, translations just shift up and down or left and right. And dilations is going to stretch or compress. Okay, that's probably going to be dealing with your slope changing. Here this is in table form. So if this is f of x, and we know that f of x is shifted 4 to obtain g of x, we're going to have to add all of our 4 to all of our f of x values, which are here. All right, so your x values don't change, but your f of x values are going to add 4 each time. So we started with 1, we're going to add 4 to get 5. We started with 2, we add 4 to get 6. We started with, I'm sorry, no, backtrack. We started with 8 that time, which will give you 12. Okay, then we'll go to the next one. At 3, it was 27, so we add 4 to that. That's going to be 31. At 64, we're going to add 4 to that, which will give you 68. So simple as that. All right, pause the video here and write down these notes. Your vertical and horizontal translations are just going to shift the whole figure up or down for vertical or left or right for horizontal. Your dilation is going to have a multiplication factor. To make it stretch, it's going to be multiplied by something bigger than 1. To make it compress, it'll have to be between 0 and 1, that value. So we're going to match the description to the transformation. Shift f of x 3 units upward. The way that's going to look is that you're going to have your function, and you're going to just add 3 to it, all the y values. We're going to shift f of x 3 units to the left. Anytime you're going left to right, we're dealing with being inside the parentheses. Okay, now notice how we're adding 3, but when I plug in a value to make this 0, that's where that minus 3 comes in. So that's telling you got to shift to the left to get this to work. Compresses 5 of x by a factor of 1/3 toward the y-axis. Okay, so we're going to use this one here because if I plug in 3 times 1/3, that gives me the value of 1, which we're looking for. Okay, so dealing with the ones that are going toward the y-axis and being smaller, it's going to be put within the parentheses. Okay, this one here is going to be a because we're stretching. So when we're stretching, it's going to be on the outside of the function. Functions, we can think about a parent and a child relationship. The parent function is always the function you begin with. It's the most simple one. It's like in its most simplest form. So the parent function for all linear equations is f of x equals x. That's the same thing as y equals x. Okay, so it's the one that goes through the 0, 0 y-intercept, and it's going to be your most simple slope. Okay, so the child function is g of x is going to be x plus 4. That's an example of being shifted up. So the g of x is actually going to be equal to the f of x plus 4. And it transforms the graph of y equals 2x into the graph of y equals 2x minus 4. Which statements correctly describe this transformation? Okay, so I'm going to go through and look at each of these. So it looks like to me like these 3 are kind of similar. And then these 3 are kind of similar. Let's see which one works. Okay, it is the graph of y equals 2x translated 4 units to the right. That doesn't make sense because we're taking away. Is the graph of 2x translated 4 units downward. That makes sense because we're taking away 4 from all of the functions, the y function. Okay, so the bottom ones is the graph of y equals 2x translated 2 units to the right. Is the graph of y equals 2x compressed vertically 4 units to the left. Is the graph of y equals 2x stretched vertically. Okay, none of those make sense. Okay, so let's think about them a little bit differently. So if we were to graph this, we could actually graph this on does moves to see what's going on, because one of those has to be right. All right, so if I look at this, I want to graph both these. Y equals 2x, and I'm going to graph the other one as y equals 2x minus 4. So obviously, the first one was easy to find because you're shifting downward. All right, so what we can do is we can talk about, okay, I know that one's right. We can see if one of these other ones will match up with that blue line. So if we do this, we can say that y equals 2 times x. Now if I want to go to the right, I want to think about translating it backwards. Okay, that's going to go too far over. That's going to shift it 2 units to the right. Oops, hold on a minute. That might be right. Here we go. So let's change it to 2. So that does match. That one does work. Okay, it's the graph of y equals 2x compressed horizontally 4 units to the left. All right, so that's going to mean we had to do this horizontally. And 4 units to the left. Not quite. And we got this being stretched vertically and 2 units upwards. So if we're stretching it all, that's going to change the slope. So those can't work. Okay, so those are the only ones that will work for that one. All right, looking at reflections. Okay, reflections is going to be where you're taking the opposite of the whole function, which means you will reflect across the x-axis. Or if you reflect within the parentheses with an x value, it's going to reflect across the y-axis. Okay, so each statement describes the transformation of the graph of f of x equals x. Which statement correctly describes the graph of g of x if g of x equals f of x plus 7? All right, so we would take f of x and we're going to translate it 7 units up because we're adding 7. Okay, and that's it. So if you do get a question about reflections, we're just dealing with a negative value.